So today we're going to see integer programming problems. So in these integer programming problems, so now the given objective functions maximize z equal to 7x1 plus 10x2 subject to minus x1 plus 3x2 less than or equal to 6, 7x1 plus x2 less than or equal to 35, where x1, x2 are greater than or equal to 0 and integers. So we will do as it is, like normal linear programming problem to get optimal solutions. After getting optimal solutions, we need to check the values of x1, x2 or integers. If we don't get values of integers, then we will do the additional iterations using Gomarian constraints method. So we can solve the integer programming problems using two methods. One is Gomarian cutting plane method, another one is branch and bound method. So now we're going to solve this problem with Gomarian cutting plane methods. So now first we have to convert the this is canonical form, we have to convert into standard form. So while converting canonical form into standard form, so how many here subject functions are here? To convert this less than or equal to, we have to add one slack variable in the first constraints. Similarly, we're going to add an additional one more slack variables in the second constraints. So totally two constraints S1 and S2 we're going to introduce in the constraints 1 and constraint 2. That we're going to add in the objective function with the 0 coefficients. Now maximize z equal to 7x1 plus 10x2. We write subject to functions. Here first equation is minus x1 plus 3x2. To make it equal to 6, we are going to add one slack variable s1. In second constraint, 7x1 plus x2 plus, to make it into equal, less than or equal to type into equal type, we are going to add another slack variable s2. So for making the equations normalized, we use 0 s2 here, 0 s1. So that will help us to for the initial iterations. So here x1 and s2 are introduced in this constraint, so that I have to use in the objective function with 0 coefficient, 0 s1 plus 0 s2. So now this is equation 1, equation 2. We are going to substitute non-basic variable x1, x2 value to 0 to find the initial basic feasible solution. To find initial basic feasible solutions, substitute non-basic variable x1 equal to 0 and x2 equal to 0 in equation 1 and 2. So what we will get, so entire this value going to be 0, already it is 0. So s1 equal to 6 and s2 equal to 35. So here we will get s1 equal to 36, s2 equal to s1 equal to 6 and s2 equal to 35. So this is, we obtain initial basic feasible solutions. Now with that we are going to do the iterations. So in iterations in table, so first we are going to write basic variables, coefficient of basic variable here. So what are the variables here? x1, x2, s1, s2 and then quantity. So above the basic variable we are going to write down the coefficient of objective functions. And in this basis, what are the initial basic feasible solutions we obtained here? S1, S2. S1, S2. This value I am going to substitute, and then in coefficient of objective functions, x1 coefficient 7, x2 coefficient 10, x1 coefficient 0, s2 coefficient 0. So now in here basis s1 and s2 I am going to write down. Now coefficients for here, objective function coefficients 7, 10, 0, 0 we taken from the objective functions. Now S1, what is we have above in S1? 0. So that we have to write down over here. What do we have above in S2? 0. That we need to write down here. So in this, in table, S1 in which equation we introduced? In equation 1 we introduced. S1 we introduced in the equation 1. So in that equation, x1 coefficient minus 1, x2 coefficient 3, s1 coefficient 1, s2 coefficient 0, and quantity B here is 6. So now this is why I have to write inside the table for respect to S1 row, x1 coefficient minus 1, x2 3, s1 1, 0 and 6. Similarly, S2 I introduced in the equation 2 where x1 coefficient 7, x2 coefficient 1, s1 coefficient 0, s2 coefficient 1 and quantity 35. So here 7, 1, 0, 1, 35. So now we're going to calculate Zj. So here 0 into minus 1 plus 0 into 7. How are we going to calculate 0 into and 0 into 7? We have to add 0 into minus 1. 0 into minus 1 plus 0 into 7. Totally we will get 0 into minus 1, 0, 0 into 7, 0. So we are adding both value, it is going to be 0. Since both these values are 0, so entire 0 into 3 plus 0 into 1, so also going to be 0. So since these coefficients are 0, all value is going to be 0. So next we are going to find Zj minus Cj value. Here this is Zj values, this is Cj value. 0 minus 7 minus 7, 0 minus 10 minus 10, 0 minus 0 0 0. So for here objective function here given is a maximize z. So for optimal solution for objective function here is, so optimal solution for objective function, if it is maximize case, Zj minus Cj should be greater than or equal to 0. But here Zj minus Cj are not greater than 2 values are equal to 0, but remaining 2 values are negative values. So since for all Zj minus Cj value are not greater than or equal to 0, we need to improve further. So here first thing we have to find key column. So finding key column, now lowest value in the maximum objective functions, if we don't get optimal solutions, the lowest value, this is minus 10 is the lowest value, that we have to take it as a key column. So this is the key column values. The value respect to the variable, it is key column respect to variable is the entering variable. And next we have to find key row. For finding key row we need to first find theta value. Theta will get by dividing quantity with key column value. This is key column value. Entire we called as a, this entire part is a key column value. So quantity 6, key column value 3. So theta here is 6 by 3 will get 2. For here 35, B here is 35, key column value here is 1. So 35 by 1 equal to 35. So here theta, so after finding theta we have to choose lowest positive as a key row. So here among these two value, lowest positive here exists only in the first row, that we will take it as a key row. So key column, key row intersection point here is key element or pivot values. So here respect to the key row value here is a leaving variable. So in next iteration, in that place x2 will occupy. Now so now finding if there is any negative values or infinities we arrived in this theta, we will ignore it. Only positive ratio we will take it as a key row. Among this positive ratio we will choose lowest positive ratio. So now we need to find iteration value. For iteration value, first here you have to find value for the key row. So S1 row. For iterated value, for key row, so key row iterated value here is row value divided by key element. So here row value, what is the row value here? So first, what are the values we need to find iteration for x1, x2, s1, s2 and the quantity. For s1 row, that is a key row. So here key row, key element we find, key element what we find 3. We can take values. Key element find 3. So these are the row value -1, 3, 1, 0, 6. -1, so -1, 3, 1, 0, 6. This is the row value. So row value we substitute divided by key element. So key element here is 3. So -1 by 3, 3 by 3, 1 by 3, 0 by 3, 6 by 3. So what happens? -1 by 3 I will get -1 by 3, 3 by 3 I will get 1, 1 by 3 I will get 1 by 3, 0 by 3 I will get 0 by anything 0, 6 by 3 I will get 2. Now for S2 row, for remaining rows, how we calculate here? First here key column value for this row we have to write down. Here key column value, what is the key column value for the S2 row? 1. So that you write down. So remainder, first you write down the row value 7, 1, 0, 1, 35. First for x1, what is the row value? 7, 1, 0, 1, 35. After this, after writing the row value of remaining rows, next you put minus, what is the key column value we have in this row? 1. So -1, -1, -1, -1 and -1. After that you have to multiply with the iterated value of key row. What is why we got for x1? -1 by 3. So what we got for x2? 1. What we got for s1? 1 by 3. What we got for s2? 0. And for here quantity we got 2. So now when we simplify here, 7 plus 1 by 3, here 1 minus 1, 0, here -1 by 3, here 1, here 33. Even if you simplify this value, you will get 22 by 3. So now these are the iterated value for the S2 row. So in next iteration, this value I am going to substitute. So next table, so BI value, quotient of BI, so x1, x2, s1, s2, quantity B, and here Cj value 7, 10, 0, 0. Here x1 is a leaving variable in that place, x2 is arriving, so x2, s2. Here x2 quotient, what is there in the quotient? 10. For s2, 0. That we write down. So while you after you iterate value, you substituting very careful. Since this is the first time key row can be any row, so you have to accordingly write down. S1 is the first row. This problem we don't have any things, but in next iteration, if S2 is a key row, we will first find the key row values, then only we will find the remaining values. So you have to appropriate row values, you have to fill in the next table. Here in this S1 row is the key row, that is the first row, minus 1 by 3 1, 1 by 3 0 2, minus 1 by 3 0, 1 by 3, sorry, minus 1 by 3 1, 1 by 3 0 2, 0 so minus 1 by 3 1, 1 by 3 0 2, and next value 22 by 3 0, minus 1 by 3, 22 by 3 0, minus 1 by 3 1 33. So next after writing this, we are going to calculate Zj value. So Zj, how we calculate? This value multiple with, so I will show you separately, 10 into minus 1 by 3 plus 10 into minus 1 by 3 plus 0 into 22 by 3. What will happen? 0 value, once we multiply with value, it is going to be 0. So 10 into minus 1 by 3 minus 10 by 3. So this value you can ignore it. Next time 10 into 1, 10 plus 0 into 0. So here total you will get 10. Here 10 into 1 by 3 plus, so here again 10 by 3. Here 0, here you will get 20. Now Zj minus Cj value we will calculate to find the optimality. So minus 10 by 3 minus 7, minus 10 by 3 minus 7, what will get? 3 7 minus 21, so minus 31 by 3. Here 10 minus 10 0, 10 by 3 minus 0, 10 by 3, 0 minus 0 0. Still for optimality conditions, for all Zj minus Cj should be greater than or equal to 0, but here one value is negative value. So since for all Zj minus Cj are not greater than or equal to 0, we need to improve further. We don't get optimal solution. So now here only one negative value, so there is no problem in selecting the key column. So this is the lowest value, so that will take it as a key column. So this is key column and the respective variable is the entering variable. Next part, after selecting key column, we have to calculate theta to find the key row. So theta here is quantity divided by key column value. So here quantity here is 2. This value here is minus 1 by 3. See, A divided by B by C, you can write equal to A into C by B. Value won't change. So same aspects I am going to use. 2 divided by minus 1 by 3, I am going to use 2 into minus 3 by 1. So I will get minus 6 value. So here similarly here 33 multiple with 3 by 22, I will get 3 11s are here, 2 11s. So here 9 by 2 I will get. Now listen, here negative value, here only one positive value. So in this among two ratios, one is negative ratio. Negative ratio we don't choose as a key row. So there is only one positive ratio that we will choose as a key row. So in this respective here, this is the key row value. Intersection here is the key element, and then this is the leaving variable. So in next iteration in this place x1 will occupy. Now we have to calculate for the iterated value. We know iterated value first. For iterated value so x1, x2, s1, s2 quantity. So here x1, x2, s1, s2 quantities, and x1 in first row, x2 first we have to find for the key row, that is s2 row. So what is the row value here? 22 by 3 0 minus 1 by 3 1 33. You write down as it is. 22 by 3, 0 minus 1 by 3. Next 133. 133. We know key element. So we know key element is 22 by 3. So this row value I am going to divide it by 22 by 3. So instead of you can use, when there is a fractional value in this key element, instead of dividing you can multiply with reciprocal. Instead of dividing by 22 by 3, you can use multiple with 3 by 22. So this is how I am going to changing it. So what I am going to do, 22 by 3 multiple with 3 by 22. So 0 into 3 by 22 minus 1 by 3 into 3 by 22, 1 into 3 by 22, here 33 into 3 by 22. So here I will get 3 will cancel, so this value will be 1. Here 0 into anything going to be 0. Here 3 will be cancelled, minus 1 by 22. Here 3 by 22, 1 into 3 by 22. Here when you strike out, 3 11s are 33, 2 11s are 22, so 3 into 3, 9 by 2. So now for x2 row, now we calculated iterated value for the key row. Now the next remaining row here is x2 row. So x2 row value here is minus 1 by 3, 1, 1 by 3, 0, 2. First write down minus 1 by 3, 1, 1 by 3, 0, 2. So row value I written. After that I have to write minus, here key column value for this row here is, key column value here is minus 1 by 3. If key column here is minus value, you have to add here. So minus, already 1 minus, so plus 1 by 3. If it is key column positive, you use minus. If it is key column negative, use plus. Plus 1 by 3, plus 1 by 3, plus 1 by 3, plus 1 by 3, plus 1 by 3. See, if key column is positive, we have to minus. If it is a negative, we have to add. Then after that, we are going to iterated value of key row 1. We have to multiply with iterated value. Here minus 1 by 22 into 3 by 22. Here iterated value here is 9 by 2. So this is the way we are going to do for all the iterations. Please remember this method. Next, so what we will get here, minus 1 by 3 plus 1 by 3, we will get 0. Here 1, 1 by 3 plus my here 1 by 3, if you take 1 minus 1 by 2, 22, 21, 1 by 3, if you take common, 1 minus 1 by 22. So here 22 minus 1, 21 by 1 by 3 into 21 by 22. When you strike out here 7. So 7 by, you will get 7 by 22. When you strike out 7 times it will go. So here 3 will be cancelled. So 1 by 22. Here 3 times will we can strike out. So 3 by 2. Here 2 into 2, 4 plus 3, 7 by 2. So now we got all the values. This we are going to substitute in the next iterations. Now we have to be very cautious while substituting this value. Next here S2 row, that is S2 row in this second row. What you do, straight away you write down this value in the first row. Don't write like this. So now or you can use that way also, not a problem. Basis, coefficient of base. Here 10 into 1 by 22, here 7 into 3 by 22. 10 into 1 by 22, 10 by 22, here 21 by 22. So 31 by 22. Similarly here 70 by 2, here 63. So 133 by 2. So now Zj minus Cj value, 7 minus 7 0, 10 minus 10 0, here 63 by 22, here 31 by 22. Since for all Zj minus Cj are greater than or equal to 0, but we obtain the optimal solutions, but the x1 value here is 9 by 2 and x2 value here is 7 by 2. These are all not integer solutions. So we obtained non-integer optimal solutions. So for now, for integer solutions, now, so to find the integer solutions, we are going to find the what is the b value. Here b quantity of x1 here is 9 by 2 and x2 here is b x2 here is 7 by 2. So both are not integers, it is a fractional value. So what are the fractions we got here? For here 7 by 2, the fraction value alone here is 1 by 2. So 9 by 2, so 8 plus 1 by 2, that is 9 by 2. So 9 by 2, how we can write? 8 plus, so 9 by 2 we can write 8 plus 1 by 2. Sorry, 4 plus 1 by 2. So similarly 7 by 2 we can write 3 plus 1 by 2. So here fractional part here is 1 by 2. Similarly for 9 by 2 fractional part 1 by 2. So now we have to choose maximum fraction to introduce Gomarian constraint. Since both are same fractions, so we have to choose maximum fraction value. So maximum fractions value, how we going to calculate? Maximum arise. So here what are the value in this x1 x2, that we have to write down 0 1 7 by 22, here 1 by 22. So in this fraction value here x1 x2 s1 s2. So here this fraction value here is, here fraction value no, here also fraction value 0, here fraction value 0 plus 7 by 22, fraction value 7 by 20, here 0 plus 1 by 22. So here fraction value, here fraction value. So here first row maximum of, how we going to find the maximum of Fij divided by summation Fij. For the x2 row, this value what we will get? Fraction value x2 row fraction value 1 by 2 whole divided by summation of Fij means the entire row. Here fraction value for x1 fraction, no fraction value. x2 although rounded value, there is no fraction value. For s1 fraction value 7 by 22, s1 fraction value 1 by 22. So how, what will get? 1 by 2, so divided by, here totally what will get? 8 by 22. So here we even simplify 1 by 2 into 22 by 8. So 11 times will go, so 11 by 8 for x2 row fraction value. Similarly for x1 row fractional value here is 1 by 2 divided, here fraction value, here negative fraction we cannot use, here 0, here what are the values they given? 0 1 0 minus 1 by 22 and 3 by 22. So if a lesser than value we can take it as a here negative value, how we can write? 1 0 1 plus 0, this is second part is negative value, here 0 plus 0. Here how we can write? 1 minus 1 plus 21 by 22. When you simplify 22 into minus 1 minus 22 plus 21 minus 1 by 22. So this, so one value, the denominator, the numerator value if you deduct that, you can write it in the positive. So here 0 plus 3 by 22. So here fraction value 0 0 21 by 22 3 by 20, that we have to write 0 plus 0 plus 21 by 22 plus 3 by 22. So how we can write? Here 1 by 2 divided by this, we will come 24 by 22 when you simplify 1 by 2 into 22 by 24, that will comes 11 by 24. So among this maximum value here is, this is the maximum value. X2 row is the 11 by 8 is more than this value. So this we will introduce the Gomarian constraints. So this is the maximum value we will got for this, for X2. So in that row I am going to introduce Gomarian constraints. So Gomarian constraints here, S3 dash equal to summation Fij Yij minus Fij. This is the Gomarian constraints I am going to introduce in the X2 row. S3 dash is the Gomarian constraints. Write down S3 dash as it is. Summation Fij, this is the summation Fij. For X1 there is no value, so 0 X1 plus 0 X2. Here S1 value here is plus 7 by 22 S1. Here plus 1 by 22 S2 minus Fij value here is fraction value we got in the quantity. What is the fraction value we got in the quantity? 1 by 2 minus 1 by 2. You, apart from this quantity value, you bring everything into the one side. So what you will get, 0 will doesn't make any negative, 0 S1 plus 0 X2. This will comes minus 7 by 22 S1 minus 1 by 22 S2 plus S3 dash equal to minus 1 by 2. So this value I am going to add in the final iterated value. In this I am going to add S3 dash value to complete this. So next in next table. So next here, basis, coefficient of basis variable. Here x1, x2, s1, s2. Another Gomarian constants we introduce. Then quantity. Here 7, 10 for objective function coefficient. Remaining value you can keep it 0. For even for Gomarian constants, you objective function coefficient should be 0. Remainder values, previous last iteration table, what we got here is for x2 0, 1, 7 by 22, 0, 1, 7 by 22, 1 by 22. For S3 dash we use 0, for quantity 7 by 2. For x1, what is the value we got? 1, 0 minus 1 by 22, 3 by 22 and 9 by 2 is a quantity, so S3 dash is 0, here 9 by 2. Next, S3 dash value again you need to add over here, S3 dash. X1 coefficient 0, x2 coefficient 0, S1 coefficient minus 7 by 22, S2 coefficient minus 1 by 22, and S3 here is 1 and here is minus 1 by 2. For x2 coefficient, objective function coefficient 10, x1 7, x3 0. So Zj value doesn't have the same value, 10 into 0 plus 7 into 1 plus 0 into 0. So here 7. Similarly you will get 0. You will get 63 by 22. You will get 31 by 22, 0, here 133 by 2 you will get. Zj minus Cj value you will get 0, 0, 63 by 22, 31 by 22, 0. But here all value are all are greater than or equal to 0, but in this Bi there is a negative value exist. So we have to solve this problem in the Bi also should be, since for all Zj minus Cj greater than or equal to 0, but for all Bi are not greater than or equal to 0. This also has to be 0 to get the optimal solutions. So if there is a negative value, now this as will take it as a, now this problem, if in quantity we have a negative, this we can solve by dual simplex method. So negative value will take it as a key row and then we have to calculate theta equal to, for maximum case minus, for theta for maximum case minus of Zj minus Cj divided by key row value. This is the key row value. Understand? So in this key row value I am going to 0 divided by 0. So theta here is, you are going to apply this formula. This is Zj minus 0 divided by 0. Total is going to be infinity. Again infinity. Here 63 by 22 into, instead of 63 by 22 dividing by minus, here instead of minus 22 by 7. So 22 cancel will be 9 times will go. So here plus 9 I will get. Similarly for here 31 by 22 minus into minus 22 by 1 I will get plus 31. Here 0 by 1 is going to be 0. So here among this maximum value where is exist, that will in this here lowest value here is, lowest ratio will be taken as a key row. Here key column, here lowest ratio here is 9, that will take it as a key column. So now this is key element. So again we need to do the iterations to get the answer. Now here iterated value for 3 row we have to calculate. This is entering variable, this is leaving variable. So now first where we got key row, this is the key row. For that value we have to find what are the value x1, x2, s1, s2, s3 dash and quantity b. We are going to find values x1, x2, s3. For this value we are going to find the iterated value. First here s3 dash row, that is the key row, that value, first row value 0 0 minus 7 by 22 minus 1 by 22 1 and quantity here is minus 1 by 2. So now this value I am going to divide it by the key element minus 7 by 22. So instead of, when the values are fractional, we multiply with reciprocal, minus 22 by 7 minus 22 by 7 multiple minus 22 by 7 multiple with minus 22 by 7 multiple with minus 22 by 7 multiple with minus 22 by 7. So here 0 multiple with value is going to be 0. Here also 0. Here will be cancelled out. 7 will be 7. 22 cancel. Minus into minus will become plus 1. Here also 22 cancel. Minus into minus plus 1 by 7. Here minus 22 by 7. Here 2 when is strike out 11. So minus into minus plus 11 by 7. Similarly for x2 row and x1 row is this is key. After calculating iterated value for the key row, we go for next row value x2 row. X2 row key column value here is, x2 row key column value here is 7 by 22. First you write down the row value 0 1 7 by 22 1 by 22 0 7 by 0, 7 by 2. So after writing the row value from the table, previous table, you here key column value positive, you have to minus 7 by 22, minus 7 by 22, minus 7 by 22, minus 7 by 22, minus 7 by 22. In bracket iterated value of key row. Here iterated value for here 0, here also 0, here 1 we got, here 1 by 7. Here we got minus 22 by 7. Here we got 11 by 7. When you simplify here, when you multiply with 0, 0 minus 0 going to be 0. Here this entire part going to be 0. So 1 minus 0, 1. Here 7 by 22 minus 7 by 20 will get 0 value. Here 7 will be striked out. So 1 plus 1, 22 is common base, we can take 22 in numerator. 1 plus 1, sorry, 1 minus 1 becomes 0. So totally here this 0. And here minus 7 by 22, 22 can cancel, 7 also cancel, minus into minus plus. So here 11, so we can strike out for 2 times, 7 also can strike out. Here 7 by 2 minus 1 by 2, so 2 when you take common, 7 minus 1 by 2, 6 by 2, it will give 3. Similarly for x1 row, key column value here is key column minus 1 by 22. For x1 row, key column value here minus 1 by 22. So here 1 0 minus 1 by 22. And 3 by 22, 0, 9 by 22. So here minus 1 by 22, that if it is a key column negative, we have to add 1 by 22, 1 by 22, 1 by 22, 1 by 22, 1 by 22 plus 1 by 22, and in bracket we will multiply with iterated value of key row. Here is 0, here also 0, for this value also 1. Here we got 1 by 7, here we got minus 22 by 7, for this value we got 11 by 7. When you simplify 0, when you multiply, it's going to be 1. Here 0, here minus 1 by 22 plus 1 by 22 become 0. Here 1 by 22 when you take common, 1 by 22 if you take is a common value, remainder what will have 3 plus 1 by 7. So here 1 by 22, 7 3 is 21 plus 1, 22 by 7 will give, so 1 by 7 you will get for this value. Here 1 by 22, 22 will cancel, minus 1 by 7. Here 2 times will go, so what happens here 14, 1 by 2 when you take common, here 9 plus 1 by 7, 64 by 2, so here 7, 64 1 by 2, 64 by 7 we can write 32 by 7 this way. So I got 1 0 0 1 by 7 minus 1 by 7, 32 by 7 for the x1 row. So this value I am going to use for the next iterations. For base is variable, coefficient of base is x1, x2, s1, s2, s3 dash, quantity, coefficient value 7, 10, 0, 0, 0. So here in first what we got here x2 row value and then x1 row, then s3 is leaving variable in this place, s1 will occupy. So x2, x1, here s1 will come, x2 value 10, x1 value 7, s1 coefficient here is 0. First here x2 row value 0, 1, so you should not write in x2 row value this value. You do make mistakes in this part. Since we calculated S3 value, key row value we will calculate first value, but the respective row value only we have to substitute. Here first row here in the previous table is x2 row, so 0, 1, 0, 0, 1, 3 we have to substitute. 0, 1 in x2, 0, 1, 0, 0, 1, 3. In x1 what we got? 1, 0, 1, 0, 0, 1 by 7 minus 1 by 7, 32 by 7. For x1 what we got? 0, 0, 1, 1 by 7 minus 22 by 7 and 11 by 7. So next ZJ value as it is we calculate. Here 10 into 0, 0 plus 7 into 1, 7. So here 7, 10, 0, 1, 10 minus 1, 3. Here 30 plus 62. So ZJ minus CJ. The simplification you can do it. 10 into 3 plus 7 into 32 by 7. So 7, 7, 30 plus 32, 62. Now ZJ minus 0, 7 minus 7, 0, 10 minus 10, 0, 0, 1, 3. Since for all ZJ minus CJ are greater than or equal to 0, but this all BI also greater than or equal to 0, but x1 is not negative, but bx1 equal to 32 by 7 is not integer. So we are going to introduce Gomarian constant since this is only, so fraction of this part here is 32 by 7. We can write 4 plus 4 by 7. So 7, 4, 28 plus 4, 32 by 7. So here fraction part here is 4 by 7. So no more fraction is not there. So we can take this as a, introduce Gomarian constraints here. So in this second year, so we will find another solutions. Here 4 by 7 and 11 by 7. So among this we have to use here one more fraction is there. So 4 by 7 here fractional part here is here also 4 by 7. 11 how we can write 1 plus 4 by 7. So here also 4 by 7 are there. So once both fractions are equal, again we need to find maximum arise. We have to choose maximum from the Fij divided by summation Fij. For here x1 row what is the fraction value here? 1 by 7 minus 1 by 7 how we can write? Minus 1 plus 6 by 7. So here fractional part here is 6 by 7. Instead of 1 by 7 we can use 6 by 7. So in x1 row 4 by 7 divided by here 1 by 7 plus 6 by 7 will get 4 by 7 into 1. Will get totally here 7 we commonly take 1 plus 6. So 7 by 7 it become 1. So here 4 by 7 will get for x1 row, for s1 row fraction for 4 by 7 whole divided by here fraction also 1 by 7. Here minus 22 by 7 how we can write? Minus 4 plus 6 by 7. So that 7 into 28, minus 28 plus 6 here 1 plus 6 by 7. Fraction for minus 22 here. So fraction part should be always positive. So minus 22 by 7 fraction part we can write in minus 4 plus 6 by 7. Here also we will get 4 by 7 into 1, so 4 by 7. Even after this value is equal value. Among this, after what we need to choose in this place, coefficient of BI, which is the lowest contribution, this. Among, say, once after fraction, maximum fraction, we have to introduce Gomarian constraints. Since both fractions are equal, if both fractions are equal, we have to find the maximum arise from the calculation of Fij divided by summation Fij. Fij here is quantity fraction, summation Fij means variables, coefficients, fractions. Here that also comes as a equal value. If this also comes equal value, we have to choose lowest coefficient of basis. Here among x1 s1, lowest value coefficient here is s1. So in this place I am going to introduce Gomarian constraints. So here Gomarian constraints, here first s1, in s1 row I am going to introduce Gomarian constraints. So here Gomarian constraints, already one Gomarian constraint used. So S4 dash equal to summation Fij Yij minus Fij. Here S4 dash equal to x1 coefficient here, fraction here is 0, 0 x1 plus 0 x2 also 0, s3 also there is no fraction value, 0 s1, but s2 we have fraction plus 1 by 7, plus 1 by 7 s2. For here s3, what is the fraction I shown? 6 by 7 plus 6 by 7 s3 dash minus 4 by 7. Fraction value here is minus 4 by 7. So now bring it everything in one side apart from minus 4 by 7. What we will get? 0 x1, 0 x2, 0 s1 minus 1 by 7 s2 minus 6 by 7 s3 dash plus s4 dash equal to minus 4 by 7. So again we are going to substitute this value in here BI, coefficient of BI. Now x1, x2, s1, s2, s3 dash, s4 dash we have to introduce in this table, and quantity B. And coefficient of objective function x1 7, x2 10, remaining value is going to be 0. Here iterated value, what first value, this last iteration, what are the value in x2 row? 0 1, 0 0 1, x2, x1. In this s1 will come as it is. Here s4 dash we will add additionally. So s4 dash we will add. So x2, what is the value? 0 1 0 0 1. For s4 dash we will substitute 0. For quantity here is 3. For x1, 1 0 0 1 by 7, 1 0 0 1 by 7 minus 1 by 7. Here s4 dash we introduce here 32 by 7 quantity. S1 0 0 1 0 0 1. Here s2 here 1 by 7. Here s3 dash minus 22 by 7. This also going to be 0 here, 11 by 7 will go. For s4 dash, what we got here? x1 coefficient 0, x2 coefficient 0, s3 coefficient 0, s2 here is minus 1 by 7, s3 dash is minus 6 by 7, here is 1, here is minus 4 by 7. So now coefficient here is 10, 7, remainder is 0, 0. So we will get as it is last value. So here 7, 10, 0, 1 value. We will get here 10 minus 1 minus 1, 9. 10 minus 1 will get minus 1 by 7. Actually this part has to be 9, not 1. So 10 into 1 plus 7 into minus 1 by 7. So here is going to be 9 value, not 3. Is going to be 9. So here 9, and next entire is 0. Here 30 plus 62. This is Zj value. Now Zj minus Cj 0 0 0 1 9 0. But here since for all Zj minus Cj greater than or equal to 0, but for all Bi are not greater than or equal to 0. So again we have to use dual simplex method. This will take it as a key row. So while taking this as a key row, this is the key row we are taking it. This value will be the leaving variable. Variable respect to the key row is the leaving variable. We have to find theta. So theta here is for maximum objective function minus of Zj minus Cj divided by key row value. So minus of here 0 by 0 is going to be infinity, 0 by 0 infinity, again infinity here, minus 1 into minus 7 by 1. Instead of dividing fractional, I can multiply with reciprocal. I will get 7. Here minus 9 into minus 7 by 6, I will get 3 2. So here 21 by 2. Here I will get 0. So lowest value occur in this third row. So this will take it as a key column. This is key element. This is entering variable. So in this place S4 dash will leave, S2 will enter. So again we need to go for one more iteration of variables. What are the variables we need to calculate? For x1, x2, s1, s2, s3 dash, s4 dash, quantity b. First row value here, key row value, s4 dash row value. First we have to calculate s4 dash row. What are the row values? 0 0 0 0, minus 1 by 7, minus 6 by 7, 1, minus 4 by 7. So here key element here is minus 1 by 7. Instead of dividing minus 1 by 7, we can multiply with minus. Instead of dividing minus 1 by 7, we can multiply with minus 7 by 1, which is multiply with minus 7. So what I will get? 0 into minus 7, 0 into minus 7, 0 into minus 7, minus 1 by 7 into minus 7, minus 6 by 7 into minus 7, 1 into minus 7, minus 4 by 7 into minus 7. So this value I will get 0, this also 0, this also 0. Here I will get 1, 7 7 will be striked out. Here 7 7 striked out, 6 I will get. Here minus 7, here I will get plus 4. So S4 iterated value I got 0 0 1 6 minus 1 7 4. So next for x2 row value I have to calculate. For x2 row key column value, what is the key column value? 0. When key column value is 0, the entire value is going to be 0. First you write down the value 0 1 0, 0 1 0 and 3. If value is 0, minus 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 0. After that, iterative value of key row here is 0 we have to use. Iterative value here is 1, here is 6, here is minus 7, here is 4. So when 0 is key column values comes, so the same value will 0, 1, 0, 0, 1, 0, 3. So next time when key column values are 0, you no need to calculate, the same value will repeat. So for this time I shown you. From next time onwards, when the key column value is 0, you write down as it is the same value. For x1 row, x1 on a row, what is the key column value? 1 by 7. First, x1 row, key column value here is, for x1 row, key column value here is 1 by 7. So now what is the value here? 1 0 0 1 0 0 1 by 7 1 minus 1 by 7 and then 0 32 by 7. So next, when key column is plus 1 by 7, we have to use minus 1 by 7 for all the values. Minus 1 by 7 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 minus 1 by 7. Iterated value here is for the key row 0, for this row this value 0, for S1 iterated value 0, in key row here 1, here is 6, here minus 7, here is iterated value 4. So next, when you simplify here 1 0 1 multiply, it becomes 0, here also 0, here also 0, here will get 0, here what you will get? Minus 1 by 6 minus 6 by 6, you will get minus 7 by 7 minus 1 you will get. Here 7 will strike it out, minus 1 into 1 plus 1. Here 32 by 7 minus 4 by 7 will get 4 values. Similarly for S1 row, key column value here is plus 1 by 7. First row value 0 0 1 0 0 1 1 by 7 minus 22 by 7 0 11 by 7. So key column value is negative positive, so we have to minus 1 by 7 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 minus 1 by 7. Next iterated value of key row here is 0, for this value also 0, for this value also 0, here 1 we got, here 6, here minus 7, here 4. So what will get? 0 0 1, here 0, here minus 6 by 7 minus 28 by 7 minus 4, here plus 1, here 1, 11 by 7 minus 4 by 7 by 7 would gives 1. So we got iterated value for all the values. Next table, basis variable, coefficient of basis variable x1, x2, s1, s2, s3 dash, s4 dash, quantity b, cj value 7 10 0 0 0 0. So here what are the here row value will get? x2 x1 s1 will come, in this s4 place s2 will come. So x2 x1 s1 and then s2 will get in this table. So here 10 7, remainder is 0 0. So first here is what are the iterated value for x2 row? 0 1 0 0 1 0 3. For x1 row 1 0 0 minus 1 1 4. For s1 row 0 0 1 0 minus 4 1 1. For s2 row, that is s4 dash 0 0 1 6 minus 7 and 4. So now we calculate as it is zj value here is calculate 0. This entire 2 row going to be 0, so 10 into 0 plus 7 into 1 7 10 0 0, here is 3, here is 7 10 30 58. 10 3s are 4, 7 4s are 28, so 30 plus 28 58. Zj minus cj, 7 minus 7 0, 10 minus 10 0, 0 minus 0 0, 0 minus 0 0, 3 minus 0 3 and 7. So here since for all zj minus cj are greater than or equal to 0, for all bi are greater than or equal to 0, and then quantity b x1 equal to, here quantity here is b x1, here is b x2. or both are bx1 equal to 4 and bx2 equal to 3 are integers. So we obtained optimal integer solution.